In this section, you learned the fundamentals of reinforcement learning, focusing on how agents learn optimal behaviors through interactions with their environment and reward systems. Key concepts included the principles of agents, states, actions, rewards, and policies, as well as the differences between model-based and model-free approaches. You explored how reinforcement learning can be applied to intrusion detection systems, where it enhances the ability to detect and respond to security threats dynamically and autonomously. Building on this, you examined the use of reinforcement learning for adaptive cyber defense. You learned how this technology enables systems to adapt to evolving threats by continuously improving their defensive strategies based on real-time data and feedback. Case studies demonstrated practical applications in cybersecurity, illustrating successful implementations and the positive impact of reinforcement learning on enhancing security measures. Furthermore, you delved into the theoretical challenges associated with applying reinforcement learning in cybersecurity. These challenges include issues related to the exploration-exploitation trade-off, the scalability of learning algorithms, and the difficulties in modeling complex, dynamic environments. By understanding these obstacles, you gained insights into the current limitations and areas for future research and development. Overall, you acquired a comprehensive understanding of how reinforcement learning can be leveraged to improve cybersecurity. The lessons highlighted the importance of continuous learning and adaptation in defending against sophisticated cyber threats. This knowledge equips you with the skills to implement and evaluate reinforcement learning techniques in practical cybersecurity scenarios, fostering a proactive and resilient defense posture.